What's going on, guys? Let's cut a bundle. They're like, cut a bundle. It's a scary. Alright guys, so we got some material here. We got some 2x2 1/8" wall, square tube. There's a little bit of rod there for a separate project. But this is what we're going to be working on tonight. We're going to see if we can get the parts cut for a project that we're working on for one of the customers that we do quite a bit of work for. So I'll show you guys a drawing so you kind of have an idea of what we're working on. So we'll go over and I'll show you the drawing and then we'll get to cutting. Alright, so this is the object we're working on here. So that's what we're after. So there's 3 casters on the bottom. There's going to be 2 of these, so it comes in a set. And it's going to hold some apparatus, some fixture, something gets held by these 2 sets of casters. So we're going to start by cutting our tube. So me and Bridger are going to start working our way through our cut list, and we'll see if we can't get all the parts cut for both of these. And then we're going to use our fixture table to start getting these laid out, tacked up, fit up. We'll see what we can get done tonight. Let's go over to the saw and we'll see what we can do. Alright, so right now we just got a whole lot of cutting. So we're just going to sit and cut this tube. While he's cutting the tube, I think I'm going to go over to the burn table, start drafting the parts that need burned so that we can get those ready to bend. So he's going to cut, I'm going to draft and hopefully cut. And then when we get all the parts ready, we're ready to start fitting it up, we'll come back to you. I'm really hoping this year we'll get a new bandsaw. That would sure help with stuff like this because the new one I get is going to do miter cuts. And so we won't have to cut our pieces and then cut it on the chop saw to get our miters or with the zip disc. This project right here, we would be able to cut the whole thing on our bandsaw if I had the new one. So here's hoping. Let's hope this is the year. New bandsaw. Hey. Alright guys, sorry about the noise. Got the table running. Bridger's running the saw, and now I'm going to add to it by using the chop saw. So we're going to cut the angles that we can on our Evolution chop saw here. This saw will only do 45-degree angle cuts. This saw will only do up to 45 degrees, so we're probably going to have to just zip disc those other ones. Let's see what we can get done here. If you've never seen these Evolution chop saws, they are pretty sweet, and they do give you perfect cut, perfect miter. And this is cool enough right now that I could put my bare hand on that and it wouldn't burn you. Kind of cool. Alright guys, so we're back out here tonight. We're working on some miter cuts. Now, I've got 8 pieces that I have to miter by hand. I was able to get the 30-degree angle with my chop saw. But this other angle, we got to put a 60-degree on it. And I don't have a saw that can do that. So, we're going to do it by hand. And we're going to use a cutoff wheel to do that. I want to walk you guys through how I like to lay out and cut miters when I have to do it by hand. There's some things that I like to do that can help you be successful at it and also keep your fingers and your face. So the first thing I like to do is check my length. So I've got a long side of an angle here and I got my long side here. So from long side to long side, I like to mark that first. That's the length of my tube. So the drawing says that needs to be 33.5, so I mark that. Then I'll take my square and I'll mark that. Okay, once I get that marked, then I'm going to rotate it 90 degrees. And we're going to lay the angle out. So I got my protractor, my angle finder, whatever you want to call it. I've got that here and I've got it set to 60 degrees. I do like to check it just to make sure I haven't bumped it and knocked it off. So we know our angle needs to go this way. So I'll put my, you can do it either way. You can do it like this, you can do it like this. For the camera's sake, we'll put it this way. Okay. All right, so I'm going to look down this and I'm going to make sure that my miter line intersects with my vertical line right where it needs to. I'm just looking straight down that. Okay. Then I'm going to draw this line. Sometimes if the steel's a little oily, you gotta get after it. Okay, so now that I've got that one drawn, then I'll put my square on here again, and then I'll draw my vertical line. I'm just looking down the vertical line to see where it intersects with my angle line. Okay, and then I like to lay out both sides when I do this. So I'm going to roll this over 180 degrees. Then I'll take my protractor again. I've got both lines. I got a vertical line here and I got it here. Hopefully you guys can see that. So I'll make sure that they intersect where I want them to. So now I've got a line on all 4 sides. Everything matched up. Okay, so now we're going to take the Widowmaker here. This is a 7-inch cutoff wheel, and we're going to cut this. I realize this isn't the most safe thing to do, but if you practice how you handle the grinder and you don't get too aggressive with it, you can avoid the majority of the mistakes that are made with this tool. So obviously I've got to keep my fingers out of the way because this is a large blade. And then what I like to do is I like to hold the grinder, my offhand, so my left hand, because I'm right-handed, I like to hold the handle with my offhand, and then I actually look down this line and I cut it like this. Now the other thing that does is with this hand here, it blocks a lot of the sparks coming off the wheel flying up in your face. That's the other reason I like my hand right there, because it's blocking the sparks. So it's kind of got a dual purpose. It's keeping me steady. I'm able to look down the blade and cut that as straight as possible while still holding it steady and blocking sparks from flying in my face. Oh, I can hear the comments now. Alright, so let's go ahead and cut this one. I'll show you guys how it goes. I've already got the first one cut. This is what it looks like. You can see how straight that is. Okay, I've beveled it just a little bit. That's going to work just fine for what we have to do. The other thing is, part of the reason people have issues with grinders and kickback and injuries is they get too aggressive. They try cutting, they try pushing too hard, and so it ends up kicking back at them. I'm going very gentle with this. So I'm just letting it cut at the speed it wants to cut. I'm not trying to force it. I just let it cut. and I don't get the blade in situations where it could bind up and kick back, because that's where you get in trouble. So let's cut this and see how it goes. So the other thing I'm doing is I'm looking where my cut already is, and I'm lining my blade up with that cut so that I can keep things straight as I do this vertical. Once my blade is through, then I roll it. So you're going to know if you're good by where your marks are on the corners here. So I'm actually just a little bit off. It's not a big deal, I can correct that. So I'm going to start my cut on this corner and make my correction and just follow the line across, and it'll correct it. Okay, so then the next thing I'll do is I'll look down this, and I can see that I've got a little bit of a arc on the heel and on the toe. So I'll throw my flap disc back on. Okay, so then I'll look down it again. Everything looks good. Sometimes I'll set it on the table and compare the gaps on either side, and they're good. There's my miter. Okay? I can only imagine the comments this is going to attract. But I did think there was some good stuff in there. Hopefully it helps someone out. Obviously, if you're more comfortable doing this with a portaband, do it. If you're not comfortable using a grinder like this, don't. That's usually when people get hurt, is if they try doing things that they're not comfortable doing. So I'm comfortable doing it this way, so that's the way I do it. Anyway, I just wanted to show you guys how I lay that out and how I cut it. And there are times in fabrication where you can't always use the easy tool. Sometimes you got to use the difficult tool. I'm not telling anybody to cut their tube this way and use a grinder. I'm just saying that's how I like to do it, and it works well for me. I'll leave it at that. Alright, so I'm going to go ahead and get the rest of these mitered. Once these are mitered, our parts should all be ready to go, and we're ready to start fitting. So I'm going to go ahead and get the rest of these mitered, and once I get that done, we'll come back to you and we'll be ready to start fitting. So let's see if we can get these knocked out. Okay, so I've got a couple fence blocks in the back with this back tube on here. I've marked center so I know where this tube goes. I've got my cross braces here. I've got my kicker pieces here in place. The funny thing is there is no dimension on this, so it doesn't really give you dimensions. They just want it square, basically. So I think this is going to work out just dandy. We'll put some of these clamps in here, see if we can't get this clamped down where it needs to go. So I'm using these fence blocks to slam this tube up against those. I'm going to slide this over where I need to where I can center my tube. And then I'm going to clamp this down. It does help if you twist these a little bit when you're putting them in and they're not broke in yet. I also like to use a dead blow hammer just if I need to tap something over after I get it clamped down. Works nice. It's not loud, it doesn't damage the material. It's so much nicer than just pulling a tape and making marks and holding things and having to use squares, and this is so nice. And for something like this, I don't think we need more than one clamp on each piece. So I'm leaving just enough room on the corner here I can get some weld on it. Everything's clamped down, everything's square, perpendicular. Son of a... I'm going to give you guys a bird's eye view here. Show you how amazing this is. Alright guys, we're ready to tack. One of the great things about this system is these clamps are holding it in place, holding it square, holding it straight. So I can go through and tack everything. It's not going to move. The clamps are going to hold it so it doesn't warp. The other great thing is we know the table's flat. It's machined flat. So we're not going to have any high-low. Joints all feel perfect. Goodness. So I think what I'm going to do is I'm going to pull this one out. We're going to slam another one in here, tack it up, because we got to build 2 of these. So I'll do the exact same part, get it all tacked up, and then we'll have to build the other half that goes here. So our fixtures will change. So we'll do this same part since all of our fixtures are in place. We'll hurry and throw those in here, tack those up. We'll set these to the side. We'll tack our other half and do that twice. And then we'll be able to start figuring out how we want to square this up. We're going to be able to use our new square. Kind of excited about that. And that's the plan. So let's get after it. Bingo. One of the things I haven't heard people talk about regarding the fireball table that I think is a good reason to talk about why it's nice to have one is it adds a certain level of fun to doing this. I mean, I really enjoy fabrication, I always have. But setting up all these fixtures and clamping things down, and it's just so much more enjoyable when you're able to produce a nice, straight, square, level part. And I really do believe that using a fixture table like this makes it more enjoyable. Freaking game changer. Goodness, we're ready to go. It's crazy. Everything looks good. Throw our ground on. Tack it. Crazy. Holy smokes. Alright, I'll give you guys a close-up of how I've done this. This is just mind-blowing. So, I've set up my new fireball square. I've got some Manus clamps holding this upright piece on. I'm checking this with a square on the table, and it is freaking perfect. And the reason it's perfect is because this is a machine surface X, Y, Z in all directions. So if I put a square on the side of this, it's perfect as well. This is mind-blowing. I realize I'm nerding out here, but this is I feel like this is the first time I've really been able to build a frame on the Dragon Wagon and experience the fixture thing. I have realized I still need some fixtures. I'm saving up for some of the upright pieces so that I can clamp things higher like this. They make some fixtures that are taller and they have a 90 on them, so you can clamp them, you know, up high and level things. But this is working great. There's always more fixtures you could have. So anyway, I'm loving it. So I'm going to go ahead, and I think if I rotate that, I think I can get my kicker pieces on here, and then we can tack those on. I can just take a fence block and use that as a backstop so that I can get that flush. Put a tack on the bottom, clamp the top with a Manus clamp or whatever so that I know this surface is flush, and I think we're good. The other thing I really like about this, I'm able to walk all the way around the table, and that is super nice as well, because there's times where it's nice to be on this side versus that side, especially when you're working with something, you know, this big. See, so I've got one tack on it. I can take a clamp and I can clamp this. So if we throw another Manus clamp on this, we just use the feet on it. It gets us nice and flush. I like it. Throw a tack on that. My goodness. We'll just do the same thing here. Goodness. This is freaking awesome. So I'm just trying to make sure that my feet are actually doing what I want them to as far as making it flush. Some more tacks on it. That stinking thing's all tacked. That could be a pain to just do this on a regular table and have to try to finagle this. It would have taken me twice as long. I know there's some haters out there. I've seen them in the comments. Heck, they've commented on my videos about, well, nobody needs a table that expensive, even professionals. I'm just telling you right now, I disagree. Everybody's got their own opinion, but after having done a complicated part like this, for me to be able to get everything straight and square and level and precise and do it in the time that I just did it, I haven't even been fitting these for an hour. For me to be able to do that, that's a big deal to me. I figured in my estimate that I would be fitting each one of these for an hour. So when people say time is money, for me to do this and fit both of them up in under an hour, I just made more profit. So people can say what they want about the cost of the table. The table is incredible. That's my vote. The other thing I want to mention is the Dragon scale is awesome. Because for me to do this on that table, I have to use my fireball scraper after every time I tack something up, because I get berries welded to the table. For me to just sweep it off and keep going, it's awesome. Just so you guys can understand here, I'm using fence blocks so that I can push it this way, keep it square, and then push it this way and keep it square. So I've got this surface, the surface of this square, this surface, and this surface, so I know it's perpendicular and it's not moving. This is solid. Okay, so then I'm able to take these clamps, clamp them down. Okay, now I'll take my upright. Something else I'll mention is I always like to try to match the seams, and I like to hide the seams underneath. You'll notice my seams are either on the inside or on the bottom of this frame. That's just, it's not necessary, it's just that I'm particular. Clamp it both ways. Okay, so I'm going to clamp this, but I also want to check square, so I got to clamp it so that I have enough room back here. Freaking money. Perfect. And then if I check the other way, it's perfect. That literally took me almost exactly an hour to fit both of these parts. The frames are all fit up and I can weld them out now. So when I quote a job, I always try to think ahead of time and quote the job thinking, okay, this will take me an hour to fit, it'll take me an hour to cut the parts, it'll take me an hour to weld it out, or maybe it's, maybe it's 2 hours, maybe it's, but that's what I'm saying is I try to think ahead and I try to plan on how long that job is going to take me depending on time. You try to be on the conservative side most of the time because to be competitive with your bid, that's just what you have to do. An hour for each of these is that's normally what I would charge. But that just saved me an hour. So it's just something to think about. And I love that square. Okay, so now I'm going to get these both over on the table and I'm ready to start welding these frames out. I don't like doing that on the fireball table because I like to try to keep as much of the berries and the spatter off the table to try to keep the table surface nice. Everything's tacked up. I'm not worried about it warping too bad. I'm still going to bounce around and try to avoid that, and I'll check it as I go, but we're going to weld these out on the big table. All right, let's get to welding. I'm going to start by doing a lot of these support welds on the flat side, because this is where it's going to get its rigidity and its strength to help keep it from warping. It's less likely to warp here. So I'm going to try to do those first. I'll still bounce around and then weld these inside ones to try to keep it from doing this, because that's where it's probably, I feel like that's where it's most likely going to warp. So here we go. Alright guys, so I want to show you something here. I think this is something good. as well. So it's really tight in this joint right here. It's like really hard to get the stinger in there. So for you to get your gun in there, your stick out, I'd say it's probably 1.25 inches, which for short arc is extremely difficult to weld. But I've done it on this one, and that's how I've been running these. So I'm going to put my glasses on, try to get some video of this, show you guys how I run that. Okay, so one of the things to remember here, you want to make sure you have enough gas coverage. I'm running my gas at about 18 CFH. So when you get your nozzle in there, you're filling up that cavity with gas. And so you're going to have enough coverage. You just have to kind of stick with it and make sure your arc stays stable enough, and you have to be smooth as you move your wire down the joint. So we're going to whip this downhill, and like I said, the stick out's going to be way longer than you would normally run on short arc, but for this joint, instead of pulling a stick machine out and welding it up with stick, it's going to be quicker for me to run it this way. So see if I can get some video of this with these glasses. Here we go. Okay, so here we go. You can see my stick out's getting really long. It'll stabilize. Go nice and smooth. Every once in a while it'll drip. That's okay. Just gonna drip on the table. Keep traveling. So hopefully you can see that. It's nice and consistent. Let it cool and then you'll be able to see it a little better. So that's a lot faster than getting a stick machine out and having to run that with stick. And honestly, I don't think that looks bad. So just wanted to throw out a pointer there. Alright, so while we're at it, I'm going to go ahead and run a couple of these flats. There's one here that's got a little bit more gap than the other, so you'll be able to see that. If I didn't mention it, we are running short arc today. I'm running about 19 volts, 350 inches per minute. I'm running C25 for the gas. Okay, consistency is the big thing. When I teach my kids how to weld, that's one of the first things I tell them. You'll be a better welder if you can be as consistent as possible. You want the weld the same thickness the whole way. If you're running a manipulation, like a movement, you want that to be consistent. Let's run another one here. Okay, we got a little more gap on this one. So when we get to that gap, we're going to have to slow down a little bit. And I'll actually push back into my puddle a little bit so that I don't blow it out. Alright guys, so the next step is we're tacking these plates on for our casters. I've got marks, so the drawings tell us we need to be 1 5/8 off this corner for clearance for the bolts. Pulling this with a tape, put a tack on it, and then I'll check the top end to make sure that we're square. Which we are. I've already got my caster brackets on this one. We're just going to do the same thing to this one. Get these tacked on here. Okay, so I got one left to do. we'll get these on, and then I'm gonna stand this back up. Silly me, I forgot to put this 45 kicker on the inside there. So we're gonna flip it over. I'm gonna check to see how much it's warped. And then we'll get that tacked in there. Hopefully it hasn't warped at all. I bounced around pretty good, but that's gonna be the next step. So let me get this tacked on, then we'll stand it up on the table, see if we can get that kicker tacked on. I think we got lucky. We didn't get much warpage, and that still fits like a glove. Have to check the drawings, see what the next step is. I know we've got a couple things we gotta bend on the press brake, and then we've got some spacer plates to put on, and then I've got some plates here that I need to drill and tap, but it's about time to go in the house. So I'm gonna see if I can get this all welded out and let it cool tonight. Then I can come out, clean everything up tomorrow, and obviously I'll have some, the spacer plates and stuff like that to weld on, but if I can clean the majority of it up, I think that's gonna help in the end. So I'll finish welding this out. We'll see you guys tomorrow. All right, guys, we're back at it tonight. We're working on tapping our holes for our brackets. We've got to tap these, and then we've got to break them. Once we get that part done, then we'll be able to tack these on the fixtures and get them welded out, assembled, and complete. So I just wanted to walk through this drilling and tapping process with you guys, because I feel like it's for anybody who hasn't drilled and tapped anything. We'll go back to the start. The drawing tells us we need a 1024 thread pitch. So it's a 1024 screw that's going to go in this plate. So we've laid everything out. We've got a center punch mark here where all the holes are going to go. And then if you go over here to the drill and tap chart, you can also look these up on the internet. It's nice to have one in the shop. If you go to standard tap and drill, and then if you go down to 1024, it tells you need a size 25 drill bit. If I go over here to my drill bit list, there's a 25. I ended up going with a 532, which is just a few thousandths different, and it works just fine. So I've got a 532 drill bit. I'm drilling these holes, and then I've got a 1024 tap here. So we'll show you guys how this process goes. Okay, so I'm going to line this up. There's another way to do this. If you have a DRO that this function works, you can use the DRO on the mill to actually lay out a hole pattern, but mine is not working because I've got one direction that's not working. So I've got to get a new DRO for this. It's on the list of the many things that I want/need. So I've got the drill bit lined up with the center punch mark. I'm running about 120 RPM on the mill. So we'll drill our hole. This is actually a pretty fast process once you get everything dialed in. Okay, usually sweep the chips away. Now I don't want to move the mill. This is one of the things that makes this really easy, is having a milling machine where you can center X and Y, you get it dialed in and you leave it there. So I've drilled my hole. Now I'm going to swap this out, put my tap in. I like to put the tap in tight enough that it will grab it, but loose enough that it will slip if it binds up so that it doesn't snap the tap. That's kind of the trick. So then I'll oil up the tap. I like to get it nice and oiled up. Put some in the hole. The better you oil things up, the less likely you are to snap a tap. Okay, so now I'm going to power tap this. So I've got it spinning clockwise. So I'm going to start it. Well, you can see it's kind of slowing down, so it's slipping in the chuck. And there it goes. Okay, so I'm going to stop it. I'll hit the brake so that I don't go too far and snap that off. Now I'm going to turn it on in reverse, and it's going to back out of the hole. Okay? And then you kind of have to do it by feel. When it gets to the top, you don't want to sit there or you're going to screw up the threads on the top. So you'll feel it when it quits moving on the handle of the mill, and then you're able to just hurry and back it out. And then I make sure I blow the chips out of there and off of my tap so that it's ready to go for the next hole. That process is pretty much the same anytime you're tapping something in steel on the mill, for the most part. If it's just a regular hole like that, that's pretty much the same process. I just thought there was some good information there. So we'll get these done, we'll get them all tapped, and then we'll go over the press brake when we're ready to bend these, and we'll show you what we're doing over there. Alright guys, we're over here at the brake, putting a 35-degree brake on these plates. They're going to mount like this. The whole purpose of this is so when they slide whatever it is that these are going to hold, it doesn't snag on that corner, so it's just a smooth transition in, and then there'll be a pin that goes through this. So that's what we're working on right now. We'll go ahead and bend one of these. There we go. Checked it with an angle finder and it's right on the money. So we got 6 more of these to do. So we're going to go ahead and do those. And then we've got some 1/4-inch plate to do. So I'll get these done. Once I get these done, I'll have to swap the dies out on this machine so that I can bend 1/4-inch. And that's probably my least favorite thing about this machine, is how difficult it is to swap the dies out. I wish there was a quicker, easier way. I love the machine, but my least favorite part is having to swap that stuff out. We'll go ahead, we'll get these done, and then when we come back and break our 1/4-inch stuff, I'll give you guys a look at that. Ho, ho, ho. What are we doing out here?
Working.
Nice. Got your overalls on. Teach them how to work. All right, I've got the dies swapped out. We've got our 1/4-inch plate pieces here. We got to break a 90 on there. You see I've got them marked. We'll go ahead and bend those now. Just a hair over bent. Now it's right on the money. So if you overbend it, you can tweak it back. You can see I just put it in there like that, tweaked it back just a little bit, and then I'll make my adjustment on the screen here. So this next one should be perfect, hopefully. Ooh, it's better than the last one, but it could still, I could go 1 more degree less. Money. Okay, so we got those bent on our 90. Those are ready to be welded on. So now we should be ready to go over and start fitting a bunch of this stuff. Let's go see what we can do. All right guys, we're ready to start fitting this. I apologize for the noise, but we've got a young man in training over here. A fabricator in training. And anybody that disagrees, that thinks that's not how a fabricator gets started, you're dead wrong. And I'll tell you why. Not to get off on a tangent, but I think that's what creates a good worker right there. You got to start from the bottom. You start sweeping the floor, you start grinding parts. That's where I started. That's where he's starting. When people start there, they have to work for something, and then when they achieve it, they appreciate it. Just my opinion. Don't mean to get on a soapbox, but that's how you train a fabricator right there. Or that's how they start. All right, so I got a mark here. This bracket has to get tacked on right there. So I'm gonna go ahead and tack this now. Now we got these little shims that we got to weld to the top. So I can just set these in place, just kind of feel that, put a tack on it, and I got to do it to both sides. Okay, so this calls for a 1/4 inch gap on the top and bottom to weld onto the shims, which we have. So I'm going to get one tack on the top on both sides, and then I'm able to take and level this. Could use a square for this too, but I think we're good. All right, so now we need to do the same thing that we just did. There's a set of these that go here 5.5 inches up from the bottom of the tube. So I'll make a mark, and then we'll know where to put this. And that takes a set of the shims, and then the, I don't know what you call those, these little flared pieces. So that's just about it. We do have our nylon pads that we have to mount on here. And once those are in place, and then we mount the casters on it, got to clean up everything, spatter, wire wheel, everything. Make sure everything's good and clean, ready to go. And that'll finish them up. I've got to get the rest of the parts tacked and welded on that other assembly. So I'm going to do that now. When I get to the point where I'm ready to start assembling these, we'll come back to you guys and I'll show you guys what we got to do for that. All right guys, we're back at it tonight. We got Bridge out here with us, helping us assemble these. Got one complete. You see we got the casters on. We got all these nylon pads on. The customer supplied the hardware and the nylon for the pads, but they shorted me 2 pieces. So I've got a piece of UHMW over there that's gonna have to do. Just wanted to give you guys a look of one assembled and all cleaned up. See, we cleaned all the spatter off of it. And Bridger's putting the pads on the top here. So this nylon cuts pretty good. I've been using my little Portaband vertical bandsaw to cut these. It does leave a little bit of a burr on the edge, but I just use my pocket knife and shave that off, and it's no big deal. Then I take my belt grinder around the corners, and hopefully you can see that I've countersunk those with a countersink bit. So we'll get this last one assembled. When we get everything all done, we'll set them down on the floor, kind of show you guys what their purpose is, and that'll wrap it up. So we'll get to that point, we'll come back to you. All right guys, we got our last wear pad going on here. We did get our pins attached. So I just took an eye bolt. I actually ended up welding it right to this. I tried to drill a hole and tighten it up, and this steel was so cheap. So I just decided to go ahead and weld that on. And then I did the same here. Just weld that on. The pin goes in there. I actually ended up tacking some washers on there because it's a much more precise hole, and so for this pin it's like perfect. That's one thing, is burning holes on a plasma table. They're not extremely accurate, so for something like this where you're using a pin, I figured that was better. So if we come over here, this is what they look like. There's a big kind of a super large heat exchanger sets in this, and it's actually like, I don't know, 30 or 40 feet long, and it's used for cooling like data centers. So kind of interesting. But anyway, it'll sit in here. It sits on this little pad right here, and then the fixture must have holes in it, and these pins will run through that, and that'll hold one end, and then there will be one on the other end. Done deal. It's a good thing we had this young whippersnapper out here helping us. So that's gonna wrap this one up. As always, thanks for watching. Hope you guys enjoyed it. We kind of enjoyed it. I enjoyed spending time out here with Bridger, so that's a win. Thanks for watching. See you on the next one. So I'm going to do the same thing, put some gap here for weld, and then I just need to make sure that this surface, which I can just take a fence block, Hey! Alright guys, so we're back out here tonight, and we're doing some miter cuts on, goodness, I can just take a fence block and get a clamp, goodness, a good thing to know. So for anybody who hasn't drilled or tapped, drilled and tapped, and then I've got a 10, throw that on the floor. Whew! All right, guys, we got our last bumper pad. All right, guys, we got our last goodness. That it ended up just breaking, so there's just